Okay, question 17, the grand finale. So, in this question, we are using G is 9.8 meters per second squared. A van of mass 1300 kilograms and a crate of mass 300 kilograms are connected by a light, inextensible rope. The rope passes over a light, smooth pulley as shown in the diagram. The rope between the pulley and the van is horizontal. Okay, so initially the van is at rest and the crate rests on the lower level. The rope is taut. The van moves away from the pulley to lift the crate from the lower level. The van's engine provides a constant driving force of 5,000 newtons. A constant resistance force of magnitude 780 newtons acts on the van. Assume there is no resistance force acting on the crate. Part A wants us to draw a diagram to show the forces acting on the crate while it is being lifted. So, let's draw our crate. Okay, so there's our crate. Now there's two things happening to the crate. It's being pushed down by gravity, so the weight of the crate is going to be the mass times acceleration, so that's going to be 300 kilograms times 9.8 meters per second squared. 300 times 9.8 is 2,940 newtons. Cool. Now there's also an upward force on the crate. Now that upward force is the tension in the rope. So let's call that T. Cool. Okay, then for part 2, we want to draw a diagram to show the forces acting on the van while the crate is being lifted. So, here's our van. Now we got the weight, which is 1300 times gravity, newtons. We've got the normal force pushing it upwards. We've got the driving force of 5,000 newtons. Now we've got two things pushing it back. So we've got the resistance force of 780 newtons, and there is also that tension in the rope. Cool. Okay, then for part B, we want to show that the acceleration of the van is 0.8 meters per second squared. So, we need to get two equations here, one involving the force and acceleration of the crate, and one involving force and acceleration of the van. So, for the crate, well, we know the crate is moving upwards. So the force on the left hand side is the tension pulling upwards minus the weight. So minus 300 times 9.8. So minus 2,940 for 0. So that's the force of the crate. On the right, we know that that is mass times acceleration. So 300 A. Now for the van. Okay, so the van is moving to the right. So the force pushing it to the right is going to be 5,000. So the driving force minus the resistance force minus the tension, and then we know that that is equal to the mass of the van times the acceleration. So 1300 A. Okay, so we can clear that up a little bit. 5,000 minus 780 is 4,220 minus T is 1300 A. Okay, so what we have now are two simultaneous equations, both in terms of T and A. Now, on the left-hand side, equation 1 has a positive T. On the left-hand side, equation 2 has a negative T. So, if we add our equations together, the T's cancel out. So we get 4,220 minus 2940 is equal to 1600 A. 4,220 minus 2,940 is 1,280. So we get 1,280 is equal to 1600 A. Now, if we divide through by 1600, we get A is indeed 0.8 meters per second squared. Cool. Okay, next up, we want to find the tension in the rope. So, a lot simpler. We now just use one of our equations from the previous part and sub in what we found for A. So, if we use equation 1, we know T minus 2940 is 300 A. So, T minus 2940 is equal to 300 times 0.8. T minus 2,940 is equal to 240. Add to 2,940, we get T is 3,180 newtons. Now really, we need to think now about what gravity was rounded to. It was to two significant figures. So really we should say the tension is 3,200 newtons to 2 sig fix. Okay, then for part T, a cheeky little 1 marker, we want to suggest how the assumption of a constant resistance force could be refined to produce a better model. So let's think about this constant resistance force. As the van's speed increases, so too will the resistance force. So we should take into account this increasing resistance force to get a better model. Okay guys, that's it for this specimen paper 1. I'm now going to do specimen paper 2 in exactly the same format. If you're watching this in 2019, the 2018 papers are coming. I just can't release them at the moment. Really hope you found this useful, guys. Take it easy. Take care.